Common questions during the design of products with moving parts are, what will my product look like during normal operation? Are there any clearance violations between moving parts? And how can I create flashy presentations to help win business? Siemens NX Animation Designer is a motion simulation application for answering these questions. Let's get started with this machine. This assembly has all parts several levels deep and was not constructed with motion in mind, so some parts can't be animated across different subassemblies. For example, the slider mount was included in a subassembly that will be grounded. A unique concept in Animation Designer are rigid groups. These let you group components regardless of assembly structure. A handy color option shows the status of this process. As we select components, watch the color change. We can freely choose components without having to adhere to any assembly structure or assembly constraints, giving us total flexibility in moving whatever we want. We can choose individual components, or we can also choose complete subassemblies using the Assembly Navigator. The subtle yet important detail here is that you can move any component regardless of where it lives in the assembly structure or how the components are related to each other. Notice how we can include the small slider supports that are buried deep in some subassembly. There are also options that let you select multiple components but create rigid groups for each. This lets us speed through selection of the gripper part and its fingers. With this color option on, you can see at a glance what components can move. Rigid groups let you tell the system what can move. Now let's tell the system how they should move. Animation Designer includes most common joints for fixing, sliding, rotating, even moving components along curves. We'll fix the base so it can't move and add slider joints to allow the transport frame to move back and forth and side to side. Another slider joint will move the gripper up and down. Animation Designer also lets you start by adding joints, and rigid groups will then be created automatically. That method is ideal for simpler assemblies. We'll add some slider joints to the left and right fingers and specify some limits of travel. The last step will be to add a revolute joint that will let the gripper head rotate so it can match the orientation of the part. Let's get a glimpse of how our motion study is progressing. To verify articulation, just select a rigid group, move it around, and the model animates accordingly. We can see how parts are sliding and rotating, and it looks like our motion is properly defined. Now that the motion definition is complete, we need to indicate how fast parts should move. Animation Designer includes linear, rotational motors that run either continuously or intermittently. Defining them is simple using inverse kinematics. Let's change our display color options so any added motors are easy to spot. Just identify the start and destination of any component, and the system will create all motors to cause the gripper to move from point A to point B. Let's play the animation and see our machine in action. We can alter the sequence of operations by moving event bars in the timeline. Notice how the use of color makes it easy to identify which bar to move. Just look at the motor that defines travel and drag its event bar to the desired location. Motor sequence can be staggered or simultaneous. Each motor can have multiple events for adding a dwell or return steps. Some useful tools that aid the process are snapping and glyphs to guarantee continuous operation. You can move an event, drag the start or ends to alter the duration, mirror, or you can split an event. Now that we have the forward animation working, let's add a mirror to reverse the process. We'll use a timeline control that provides video editing-like interaction. A quick mirror operation creates the return actuation of each motor. In just a few minutes, we were able to answer the first question: what does our product look like under its normal operation? Now let's use Animation Designer to find any collisions between moving parts. Animation Designer includes interference checking that can show interference during a motion study. Options are provided to stop an animation when a collision is detected, and modes are for fast or accurate checking. We'll get a better view by zooming in and using a timeline to determine when the collision occurs. While the problem here is obvious, the fix is fast and easy with well-integrated modeling. We would also like to know the clearance between the slider and the mounting support afterwards. So we can monitor the clearance during the entire range of motion. Let's add a monitor between the faces of the slider and support. Once done, we can plot this monitor on a graph and look for any trends, maximum or minimum values. Using the timeline cursor, we can advance the model to the point of interference. Note, there is an option to stop the animation on a clearance violation. Here we see the support bar protrudes into the slider's path. Fixing the issue is just a matter of setting the support as the work part, then using modeling tools to address the issue. We could address this fix in many ways, such as specifying a precise clearance between the slider and support, or make the support the exact length as the others. Let's keep things simple and just move the face out of the way to some arbitrary distance. As we rerun our animation keeping collision checking on, we notice there are some more collisions, but we won't worry about those for now. But what about the clearance between the moving parts? Just turn on the graph and monitor the plotted values. Using Animation Designer, we were able to find and fix a collision that ensures our design is ready for production. Now it's time to create a flashy presentation to win the account. We'll create an animated video with parts in our machine fading, exploding, and a camera walking around the model, all while the machine is under its normal operation. Let's change our color option to illustrate what parts will disappear over time. Let's first make the frame disappear. You only need to establish when in the timeline this change should happen, then the amount of fade and duration. To make this process easy, there are default values to help you get started. Once added, you can change when the effect happens by dragging the color-coded event bar. We'll repeat this process for the conveyor and tabletop. Notice the simplicity of this operation in live results. As you advance the timeline to an appropriate spot, current effects are applied so you can easily set the next operation. We'll add a visibility effect to the conveyor, the tabletop, and then the transport mechanism. Once complete, let's see the results. As expected, the machine does its thing, but now parts are fading out. This is the perfect effect for peeling back the covers to let your customer see what's happening inside. Let's add another effect, but this time we'll explode parts. Again, we'll set a display color option to show any exploding components. Creating animated explodes is very similar to visibility, where you set the desired time when the effect is to happen, then choose what will explode and in which direction. It may be interesting to see the frame explode in all four directions while fading. We'll start with the left members and explode them, then we'll choose the rightmost members. During the process, notice how the use of color helps us understand the level of completion. We'll explode the front members, then the ones in the back. We'll not worry about picking all the small fastener and end caps, so some parts may not explode as expected. The default duration of each explode operation can be fixed or mapped to cursor travel. The slower you drag, the longer the explode. Explodes can be along a vector, around a vector, or along multiple vectors, which is useful when wanting to show how an internal component is removed. There are also options to explode selected components individually, which can speed defining how mounting bolts are removed, but in a sequence. At any time, you could advance the timeline cursor to get a quick preview of the explode process. And at the same time, the machine animates along with any visibility effects. Now that all explode operations are set, let's see the results. As you can see, we have greatly increased the visual appeal of this motion study. This is also the perfect tool for creating assembly and disassembly instructions. This last step will be to animate the camera. With this option, we can walk around the model. Defining the camera points is simple. Just advance the timeline cursor to the desired spot, use view commands such as pan, rotate, and zoom to get the model in the right orientation, then click a button to capture the setting. Repeat this process until you're at the end of the timeline. Animation Designer will create a smooth transition between each keyframe. You can add, delete, or redefine keyframes at any time. Now we're ready to take our animation to the customer for approval. What do you think your chances of winning business are with animated motion studies over images? In just a few minutes, we determine what our product looks like during normal operation, were there any clearance violations, and we put the results into a flashy format. Animation Designer is the perfect motion solution for any company that makes products with moving parts.